Cylinder engines come in three major types. Some are straight sixes. The most common six-cylinder engines are V6s. The Porsche 911 has always used an engine known as a flat six-cylinder, with two rows of three cylinders horizontally opposed to each other. Porsche believes there is a key advantage to the flat six design when used in its sports cars.
The biggest advantage of using a flat six-cylinder in the Porsche 911 is its low center of gravity, because it's very small. You can mount it down low in the body.
The lower center of gravity contributes to improved handling.
The lower the center of gravity is, the more stable the car is at high speeds and the cornering.
Those famous flat six-cylinder engines are made in the factory's engine assembly area.
In Stuttgart, we build in total approximately 500 engines per day.
Every 3 minutes, the plant completes a flat six engine. The plant makes more than 20 different versions of its flat six-cylinder engine, ranging from 255 to 535 horsepower. Each version of the flat six-cylinder engine has many of its own specific parts. The challenge is getting the right parts to the right place, just in time for the engine's assembly. So Porsche developed an automated logistics system. In the logistics building, a computer illuminates lights near the parts bins, indicating to a worker which parts to pick. Once the part is picked, the worker pulls a string, shutting off the light. Engine parts are loaded onto a cart. The cart is then picked up by Porsche's patented driverless transport system. Carts are programmed to take a specific route to the engine assembly area. The route takes them over a bridge and into an elevator, where they go down one floor and deliver the parts to the engine assembly area just in time. The factory has a total of 21 carts. 9 of the carts are dedicated to removing completed engines from the engine assembly area. The carts take the finished engines back up to the logistics area. But how do the carts know where to go and which path to take?
Every
5 meters, we have magnets embedded in the floor, which are covered by concrete. And between one 5-meter distance and the next 5 meters, the cart is programmed to find its way. This, for example, is such a spot.
Each cart travels over 12 miles every day at speeds of over 3 miles per hour. The people on the floor seem to know how to stay out of the cart's way, but just in case, there are safeguards.
As we can see, nothing happens even though it's carrying a heavy load, and these carts move at quite a high speed. But nothing can happen because we have a built-in safety system in there.
For every flat six-cylinder engine made, there are 3 parts deliveries to the assembly floor. The first parts delivery is pushed by hand. It contains both halves of the crankcase, the crankshaft, and pistons. Early in the line, pistons are assembled. Then the first 3 pistons are carefully put into the crankcase. Then, the crankshaft is placed into one of the crankcase halves. That first row of pistons is linked to the crankshaft. Then, a robot installs the second half of the crankcase and bolts it on. Now, the partially assembled engine travels to the main engine assembly line. Meeting that partially assembled engine, a special carrier called a crossmember. The crossmember allows technicians to maneuver the engine for easier assembly.
You can rotate the engine, you can lift and lower the engine, so that the workman always works in an optimal ergonomic position.
2 stations down, a technician puts the crossmember to work, flipping the engine on its side and installing the remaining 3 piston heads. The technician cranks the engine to check the piston linkages with the crankshaft, ensuring the operation is smooth. Next, a cylinder head is placed onto one side of the engine. The cylinder head contains valves that will let air into the cylinders and take exhaust out. Technicians put the crossmember to work again, flipping the engine, so the other cylinder head can be installed. Every 2 minutes and 44 seconds, the engine reaches a new station. Some stations are manned by human beings. Others are handled by robots.
Automation makes sense in those places where many things are repeated. If you screw 20 screws into an oil pan, it's not necessary that one employee screws in 20 screws. A robot can do that. That doesn't achieve any added value. But if you have complex assembly procedures, you need the employee.
About 2/3 of the way through the line, every engine goes through what's known as a cold test. Here, the engine is electrically cranked and turned. Its linkages and systems are checked by computer. After the test, the intake manifold is installed. The engine will breathe in its air through these plastic tubes. The engine exhales through the exhaust manifold, the last major part installed. It's taken about 6 hours to build the flat 6 engine from start to finish. At the end of the line, completed engines are taken away by the driverless transport carts and delivered to a holding area. They'll eventually be taken to the main assembly line and married to the vehicle's body. At Porsche's ultimate factory in Stuttgart, Germany, the assembly line puts together 16 different models of the 911. Each 911 will spend about 15 hours moving down the line. The line has 117 assembly stations. Workers at each station have just over 5 minutes to complete their tasks before the next car moves into place. But as they work, the line does not stop.
The line is moving continuously so the technicians can keep working and don't have to stop during the feed.